committee member for Survey for BIM as a government task group as well, so I'm involved in that and we're trying to push that forward. So I'm here today at Duncan's invitation to discuss construction layout solutions and robotic total stations. So this might not mean much to some people, so I'll whiz through it. It's only 6 or so minutes and it's my first Pecha Kucha, so we'll see how this gets delivered. So, quick agenda. I'll give you a quick introduction to Leica Geosystems if you're not familiar with us as an organisation. And then Leica have what we call our BIM field trip. So I'm going to concentrate on just one element of it, but I'll give you an introduction to where we sit amongst the rest of the BIM cycle. Our total station technologies, and then the as-built data capture afterwards. So Leica Geosystems are approaching 200 years of age. 1819 will be a big birthday party for us. 2019. Our heritage goes back to 1819, and we are a Swiss manufacturer of originally optical devices, but positioning and taking that forward into positioning solutions such as high-grade GPS. So our BIM workflow or BIM field trip encompasses the existing environment, capturing that data in 3D, taking that into a design environment, enriching that data, and then sending that data back out into the field for putting in the right place, and then bringing that to validate back into the office. So a total station, if you're not familiar with one, started life as a field light on the left, which would measure angles and distances, and you'd use a chain or a tape measure to measure the distance element. And then on top in the middle, you've got an extra device, which is the bolt-on distance measuring item. I'll speed up to get in on each slide. Today we have total stations with more mod cons, and what we have here is a multi-station that does everything we see on the side, so a lot more sophistication in terms of data capture, the angle measurement, the onboard data processing, and also point cloud data capture, what we term laser scanning. But going back to a total station, in 3 simple terms, they'll measure a horizontal angle, a vertical angle, and a distance to a point. So you can map, you can survey and capture that point, but the reverse of that is taking that design information from BIM, from CAD, into the field and putting it into the right place. So conventionally, this would be a 2 or more person team, where we've got somebody on the technology, on the instrument, that will provide those hand signals and shouting of walkie-talkies over to their colleague to get into the right place. And then we've got top Sorry about that. I'll silence that, you don't need to hear that. So we've got a quick short animation here just to put it into practice to describe what I'm talking about really. So this is a conventional total station where we've got a design model, a CAD model loaded into it, and this is relaying that into reality on a construction site, putting it into the right place relative to a position. We're measuring to the target on the pole, and then the operator will position that on the ground, mark that on the ground, and then the steel work can be dropped into the right place. And we'll see that completed with these 6 columns in place here. So moving forward to the main topic for today is robotic total stations, where you work as a one-person system. So taking that technology onto the operator's end where you're measuring. So you have a communication link from the measuring total station on the tripod over to the screen, the remote control device in front of you that then guides you into position. So we have here a couple of examples of operators doing so, all on their own. Traditionally they're called one-manners or one-man total stations, completely politically incorrect. But the term robotic total stations is synonymous with that as well. And that could be small screen, 3.5-inch screen, or a larger tablet type devices. Here we've got an example in the middle, the multi-station projecting down to a point on the ground for setting out, and on the left just a zoomed in view of measuring that point with multiple people when it could be one, because they were all interested in seeing the new gadgets and gizmos. And then laying out on the side the grid lines and the positions that we're marking. So in terms of the operator's interface, we have devices that are handheld computers, tablet computers, and then there are questions over the ruggedness, the screen size. Do you want a keypad? Do you want a completely touch screen? Lots of options depending on how you want to interact with it. But all of these require line of sight from the telescope that's measuring to where you want to be stood and positioning that point or measuring that point. And so if we integrate GNSS on the top of that target, on the top of that pole, then we have what we call a smart pole. So in this example, this pile of scaffolding is obstructing and obscuring the view, but we can continue working in our smart pole method. Then we have a short video about when you do lose that. So it will track you and follow you around until line of sight is blocked. And then with a simple button press, we have a search mechanism to turn around and re-lock back on and reacquire yourself, your target, so that you can remain productive. And then the view through the telescope is recentering back on. Software-wise, very intuitive, modern smartphone style graphics and terminology, depending on if you want a large screen, small screen, setting out a building, setting out a road, setting out a structure, whatever it may be, putting it in the right place via the simplified graphics to get you there. And things like reversing beeps. On a parking sensor on a car, you reverse closer to the wall, the beeps will beep to tell you you're getting closer to that point, so that you know when you're there. And you're not looking at the screen, but you're listening, so you don't fall into a trench or trip over some rebar. We take the design environment, send that out digitally to the positioning technology in the field, manually or via the cloud, and then on site we'll position that to set out the extension to this building that we have here. But then what's also key to complete this, or an extra part of this BIM cycle, is to capture that as built, that as constructed, that as validated part of the construction, and bringing that back into the office and maintaining that. So you've got the deviations of how good you set up the building compared to the design, and is it in the right place. But beyond setting out individual points and walking around, we have machines that can be controlled. So in here we have Nottingham Tram example, where one of our devices is controlling the paving machine that's putting the tram and the brackets on the ground into the right place to millimetre level, so that the trams line up perfectly. And then finally, the last slide we have is what we have called our 3D disto. So this is available for mostly interior and indoor positioning for MEP. So if I wanted to set out the 4 holes for the bracket for mounting the projector on the ceiling here, that could project a point onto the ceiling, put us into the right place, and then that improves the level of efficiency and productivity.
Thank you. And next we have Rob.